Welcome to Sundar's lecture. This is lecture number 75, and in this lecture we are going to see numerical problem related to RLC circuit with DC input, right? So we have seen the derivation in the previous class. See, we have taken the RLC circuit and we tend to derive the expression, and in that expression we have a second order differential equation, and in that second order differential equation what we have seen, you just see if you are going for the characteristic equation, and in that characteristic equation you will get two roots, right? One is S1 and one is S2, and if S1 and S2, then if I substitute the quadratic equation formula, so I will get S1 and S2 like this, and if I further simplify this, I will get an equation like this, right? So here we have assumed two things, one is alpha and one is omega, right? So what is alpha? Alpha we are taking it to be damping ratio, and omega we are taking it to be natural frequency, right? So this alpha depends on this value alpha. The voltage is going to store in the capacitor. The voltage going to store in the capacitor will be either over damping or under damping, or it will be critically damped. That is the three cases we have seen in the previous class. See, that is what we have taken here. See, case 1 over damped, case 2 critically damped, case 3 under damped, right? So these three methods, or maybe because of the characteristic roots, these three varies, right? If S1 and S2 are not equal, and then this will be case 1, and if S1 and S2 are equal, then it will be critically damped. If S1 and S2 are complex conjugate, then it will be underdamped. By seeing the roots itself, you can easily understand, or by getting the values of alpha and omega naught. If alpha is greater, then it will be overdamped. If alpha and omega are equal, then it will be critically damped. If alpha is less than omega naught, then it will be underdamped. So many ways you can see the three different damping scenarios in RLC circuit, right? So now we will take a numerical example and we try to get the answers, but by the answers can we see the exact graph while solving with the pen and paper? It will be very difficult. Anyhow, to understand, we try to solve the problem, and then I will show you the exact graph using the MATLAB, right? So now we will take this expression, right? So first what I am going to do, I will keep L and C as the same values for three cases. It will be 1 and it will be 0.05. I am not going to change that because we know, right? First case 1, we will go for case 1. Case 1, we are going for over damped condition. So over damped condition, what it will be? It will be alpha greater than omega naught. That's all. This condition has to be satisfied, right? So what is alpha here? So I will write it down here. Alpha is equal to R by 2L. And here what I am going to do, I will take R is equal to 16 ohms. Greater R, so that it will be over damped condition. So this will be the alpha value, and alpha is 16 divided by 2 and it will be 8, right? So alpha value will be 8, and I am going for omega naught. This omega naught will be same because what is omega naught? It will be 1 by root over LC, and this value if we substitute 1 divided by root over 1 into 0.05, I will always get this value. What is that? It will be 1 by root over 1 into 0.05. I will always get this as 4.47, right? This value, this omega naught will be same because I am not going to change L and C. I am going to change R to differentiate the different cases, right? So now you see this is 8 and that is greater than 4.47. So obviously this case is going to be overdamped, and in overdamped condition S1 should not be equal to S2. It is going to happen, right? You see, that is what we have seen, right? See here, S1 will not be equal to S2. That is what we have seen already. Anyhow, we try to drive the expression now. So for that, what I am going to do, what is S1? So we know, first of all, we know V of t expression can be written as, see, if S1 and S2 are not equal, then what is the expression? It will be A e power s1t plus b e power s2t. See, plus k1 and k2, I am not going to do that because I know this is 10 volt, then obviously it will be 10. These kind of things you have to understand by yourself. If you want to know what is these kind of how I am writing these kind of expressions, please you see my previous lectures where I have solved the differential equations for second order differential equation, for first order differential equation with DC input, with AC input. I have solved everything. Please you go through those lectures to understand these kind of things, right? So this is the expression now, and we need to find what is S1, and we know, right, what is S1. S1 formula, you see it is the S1 formula, minus alpha plus square root of alpha square minus omega naught square. So it will be minus alpha plus, right, here it will be plus square root of alpha square minus omega naught square. Now this is the expression, and we try to substitute. So S1 is equal to, it will be minus 8 plus square root of 8 square minus it will be 4.47 square, right? So if you simplify this, you will get S1 will be is equal to minus 1.36, minus 1.36, and this will be the S1 value now. And if I am going for S2, S2 will be is equal to minus alpha minus square root of alpha square minus omega naught square. So this is the formula for S2, and if you substitute the values, then S2 will be is equal to minus 8 minus square root of 8 square minus 4.47 square, right? Maybe you maybe the next part you take this is 4.5, I will tell you that. Maybe if you simplify this, then S2 comes out to be, it is minus 14.63. These are the characteristics roots now. These two are the characteristics roots. So now you can easily write down the expression, right? What is the expression of V of t now? So V of t can be written as, V of t can be written as a e power minus 1.36t and then plus b e power minus 14.63t plus 10. That's all. Now this is the expression for V, and you see this one I have not told you anyhow. This condition, for initial conditions, V of 0, I am assuming it to be 0, and I of 0, I am assuming it to be 0, right? Current through the inductor and voltage stored in the capacitor before closing the switch. Anyhow, I am not shown you the switch here. Maybe I will put a switch over here so that it will be easy to understand. It will be easy to understand. So this is the switch, right? So this is S, this is S, and now before closing the switch, these two conditions should satisfy, right? So V of 0 and I of 0 will be 0. So try to substitute V of 0 in this expression, and what will you get? What will you get? It will be, see, I will write it down here anyhow. So see, if I substitute V of 0 here, what I will get? So V of 0 tends to 0, so that it will be e power 0 value, it will be 1, right? So it will be A, and e power 0 value will be also 1, it will be B, and then it will be plus 10, right? This is the value. And if I further simplify this, what I will get? So I will get A plus B will be is equal to minus 10. That's all. This is the expression number 1. And how will you get the expression number 2? Try to find what is the I of t value, because we know what is the initial condition, the current in the inductor. So you try to find what is the I of t value. Let me take to the next page. See, I have taken V of t to the next page. See here, we know that I of t value will be is equal to C into dV divided by dt, right? So what is the value of C here? It is 0.05 into dV divided by, sorry, it will be d into V divided by d by dt into V, right? Now I have to substitute this expression, so it will be 0.05 multiplication of, and I need to differentiate this term. If I differentiate this term, what I will get? It will be minus 1.36 A e power minus 1.36t, and here it will be minus 14.63b e power minus 14.63 t, right? Plus 10 it will be 0 since it will be a constant, and if I further simplify this, then I of t value becomes I of t. I of t can be written as, I just multiply this inside, you will get minus 0.068 a e power minus 1.6360, and then this value will be minus 0.732 b e power minus 14.63 t. And now this is the value of I of t. And we know that what is the condition? We know it is I of 0 will be equal to 0, right? And if substitute here, what you will get, obviously you will get the value of minus 0.068 and then minus 0.732. Just put t is equal to 0, then this term will be cancelled out. Oh, I have left out a. It will be 6 a minus 0.732b, and that should be is equal to 0, right? So now this is the expression number 2, and solve expression number 1 and then 2 and then 2. See, I have already solved the expression number, I have already got the expression number 1, and this is the 1, and if you simplify these two expressions, you just directly put it in the calculator, you will get the answers. So a value I am getting it to be minus 11.02, and then b value I am getting it to be 1.02. That's all. Now we know both a and b, so it will be very easy to get what is the value of v of t. Anyhow, so v of t value can be written as, instead of a, you have to put this is minus 11.03, sorry, 02 e power minus 1.36t, and then plus, not s plus, it will be 1.02 e power minus 14.63t plus 10, right? This is the value. And if I go for I of t, and that is also easy because I know a and b, so you directly substitute a and b in this expression, you will get the answers. So if I simplify this, it will be 0.75 e power minus 1.36t, and then this value I am getting it to be because here it is minus, so it will be a minus value. So minus 0.75 e power minus 14.63 t. That's all. These two are the expressions we are getting for v of t and I of t. Try to understand one thing. Now what I am going to do, I am just going to substitute, see, I am going to substitute and tell you what is the values of at 0 second, 1 second, 1.5 second, 2 seconds, and then it will be a very long period, maybe up to, I will tell you 10 seconds. It will be easy to understand. Try to substitute the values. I am just taking it to be from 0 to 10. I will draw the table and I will show you. And you just see, I've just drawn the diagram. It will take long time, right? If I put all the values and put it in the calculator, you just get this expression, and instead of t, you try to substitute 0, you will get 0, and then put 1, it will be 7.12, and you see this value is getting increased to 10 after 15 seconds. Maybe at 10 seconds it will be 9.99 volts, and at 15 seconds or it may be 16, it becomes 10 volt, right? And then if you are substituting the values for current, this will be 0, right? It is 1, it is 1, 0.75 minus 0.75, it gets to 0. And if I put 1 second, 2 second, 3 second, it will, at 1 second it will be 0.19 amps, or it may be 190 milliamperes. You write it down, whichever the term you are comfort with. Maybe I have written it with amperes, so it will be 0.19 amps, and then it will be reducing to 0. After 10 seconds it becomes 0, nearly it becomes 0 amperes. Try to understand what is the difference, why we need to find these kind of values. Try to understand one thing. See, this circuit, this 10 volt is going to store in this capacitor, and how it is going to store, that is what we have seen in the previous class, right? So it will take long time to get to 10, and it gets short time to get to 10, and it oscillates over 10, under 10, over 10, under 10, and then at last it will get to 10 volt. This is the three case. This is the only three case. And this one we have seen overdamped. That is what we have seen here. So how will you compare this overdamped condition? You can go for the critically damped condition. What happens if it is critically damped condition? See, critically damped condition, see here, this take long time, right? For example, if this is the 5 volt, for 5 volt, this overdamped condition will take around, if it is 2 seconds, then at 1 second itself, this critically damped condition get to 5 volt. That is the whole idea. And see, if it is 10 seconds, maybe 10 seconds to get the 10 volt in the overdamped condition, if it is 10 seconds, and then you see at critically damped condition, maybe it will be very less time, and beyond this less time you cannot get the 10 volt. That is what we are calling it as critically damped condition. If you are going for less than that time, then it is going to oscillate. Only these three conditions you have to understand. Either it will take long time, or it will oscillate, and if it is only critically damped, it will get the less time to go to 10 volt. That is the whole idea you have to understand, right? So now what we will do, we try to find what is the value. If it is the critically damped condition, then what we need to do, this alpha should be equal to omega naught. Let me take that value and we try to solve the problem, and we will see what happens to the critically damped condition. So you see, we have gone for critically damped condition. The circuit will be same. We are going to change only the value of resistance, right? So we know what is the value of L. L will be 1 Henry. There is no change. And C will be 0.05 Farad, and there is no change in that too. And we are going to take R, which is equal to 9 ohms. That's all. That is the only change we are going to do here. So what is alpha? What is alpha here? Maybe I will write here, alpha is equal to R by 2 into L, right? So what you will get, it will be 9 by 2 into 1. So alpha value will be here, alpha is equal to 4.5. And we have seen already, right, what is the value of omega naught? We have already taken the value, it is 4.47. So what we will do, we try to get it to 4.5, nearly 4.5, right? That is the idea we are going to see in this one. Let it be 4.5, right? So what is the formula to find what is the value of S1? So what is the formula? It will be S1 will be is equal to minus alpha plus square root of alpha square minus omega naught square, right? So if you find the value of S1, and then we know what is the formula to get S2. I'm not going to do these kind of things because we have already seen these kind of things, right? So you try to substitute yourself and you try to get the values of S1 and S2 by yourself. I'm getting S1 will be is equal to S2, and that is also is equal to, I am getting it to be 4.5, because this term will be cancelled out, right? This term will be cancelled out. So the value of S1 and S2, I am just getting it to be minus 4.5. It will be minus 4.5. So this is the value now. And you see, if both characteristic equations are equal, then what is the solution for differential equation? Solution for differential equation will be V of t can be written as a plus bt into e power st plus 10 volt. This is the formula. This is the plus 10, it will be the equation value, and I am getting it to be 10. So we know these kind of things, right? Please go through my previous lectures to get how we are getting these kind of expressions, right? So what we will get, so V of t can be written as, now it will be a plus bt e power minus 4.5 t plus 10. Now we need to find what is the value of a. Again the conditions are same. V of 0 will be equal to 0 and I of 0 will be equal to 0. And if you substitute what is the V of 0 in this expression, you try to substitute V of 0. So V of 0 will be is equal to you will directly get, because this value, what is this one, this will be a, and this becomes 0. Obviously this is going to become 0, right? Because if you put 0, it will be 0, and if you put 0, this value becomes 1, so a into 1, it will be 1, so plus 10, and this value will be 0. So you will directly get what is the value of a will be is equal to what? Minus 10. Direct values. Minus 10 you will get, right? So, and also we know I of 0 is equal to 0. So what you do, you just try to get the I of t expression. What is I of t expression? It will be c dv by dt, so it will be 0.5, 0.05 into dv by dt, and we need to differentiate. Maybe I will write it down. This will be d by dt of, and instead of v, we need to substitute this. So it will be a e power minus, maybe instead of a, we can substitute the values, right? So it will be minus 10 e power minus 4.5 t, and then it will be plus b t e power minus 4.5 t, and then plus 10. It is not necessary to write, anyhow I'm just writing it down. So what you will get, so it will be 0.05, maybe you will get, you have to multiply these two, so it will be 45. So 45 e power minus 4.5 t, and then you see this is actually b is there, you take it outside, and you need to differentiate this with the uv formula, right? So we have to keep you have, if you are keeping u as it is, and then differentiate this v, and then you will get minus 4.5 e power minus 4.5 t plus, and then you have to keep this 4.5 t as it is, and if you are differentiating this with respect to t, it will be 1, so you will not get anything. So this value, and then this is 0, right? So if you further simplify this one, I'm just writing direct answers, you try to simplify the values. Maybe I of t, if I further simplify this, I am getting it to be, I will directly write I of t value, uh, it will be 2.25 e power minus 4.5 t, that is the first term, and minus 0.0, not 0, 0.225 bt e power minus 4.5 t plus 0.05 b e power minus 4.5 t. Now you see, this is the expression for I of t, and if you substitute I of 0 is equal to 0 in this expression, I of 0 is equal to 0, right? That is the condition. And if you are going for that condition, if you substitute the values, it will be 1, right? So 0 will be is equal to, this value becomes 1, so it will be 2.25, and then minus is there, and you see, if we put 0, this whole term becomes 0, right? So obviously you will get this term, and this term, in this term too, maybe this t, it is not here anyhow, this t, it is actually the t of value, this 4.5 t, right? So now you see, this value will be now, it will be 1, so it will be 0.05 b. I'm getting like this. And if you further simplify this, what you will get, b value comes out to be, further simplify this, b is equal to minus 45. That's all. B is equal to minus 45. And now you can write down the expression for v of t. So what v of t will be, a value will be minus 10, right? So what you will get, so minus 10 e power minus 4.5 t. I am just getting e power st inside. Maybe, sorry, this e power minus 4.5 t inside. So I am getting like this. So this value will be minus 45 t e power minus 4.5 t plus 10. This is the expression. And if you are simplifying, going for I of t expression, maybe there is a one step behind that. I will try to solve that too. So I of t can be written as, what you will get, 2.25 e power minus 4.5t is already there, and then minus if you multiply b 45 with this term, you will get plus, right? Already there is a minus, so it will be 10.1. Maybe there is 10. I will take it out. So this value will be 10.125 t e power minus 4.5t is there, and if you are going for this term, this has to be minus 2.25 e power 2.25 e power minus 4.5t has to be because these two terms has to be cancelled out. So for finally, if you are writing what is the value of I of t, then you will get this value is 10 plus, right? So this is plus, minus is already there, minus is already there. So now you will get 10.125 t e power minus 4.5t. Now you see we have got both values, right? V of t and I of t. What is our aim now? We have to substitute t is equal to 0 to 10 and t is equal to 0 to 10 in I of t and V of t expression. And we need to compare what happens if it is the over damped condition and in the critically damped condition. We try to do that. I will tabulate it and I will show you. And now you see I've just taken this is for over damped condition, this is for over damped condition, and this is for critically damped condition. You just substitute the values in these two expression, and that is what we are getting here. So at 0 here you will get 0 volt, and at 0.5 you will get 6.57 volt, and at 1 second you will get 9.39 volt, and at 1.5 it will be 9.91, and it will be 9.98 at 2 seconds, and at 5 seconds it becomes 9.99, and at 6 seconds it becomes maybe 9.999, and that one, and it becomes 10 volt, and it becomes 10 volts. See, this is the difference. You see, at 6.1 seconds, at 6.5 seconds even you will get 9.9 in here, but 6.1 second itself it becomes 10 volt. And you see at 1.5 seconds it is only 8.5, but at 1.5 seconds you are getting 9.91 volt here. That is the difference. You are getting so fast. Very fastly the 10 volt is going to stored in the capacitor if it is the critically damped condition, and the current value is also is going to become 0 very fastly compared to the over damped condition. You see, this value will be 0 and this will be 0.112 and then this will be 0.02 immediately, and then this is become 0.0004, and at 5 seconds itself it becomes 0. And you see at 3 seconds it is 0.013 here, but nearly it becomes 0 amperes at a critically damped condition. So voltage stored in the capacitor and current in the capacitor becomes current becomes 0 very fastly, and the voltage become 10 very fastly compared to the over damped condition. This is over damped and this is the critically damped condition, right? You just try to compare these two, you can easily understand, right? This is the graph, we have already seen this graph. See, over damped condition, it's take more time, right? For example, if this is 5 volt, then it takes around 2 seconds, and it takes 1 second, it will take the capacitor can store 5 volt of voltage, and 10 volt you see it gets to 10 seconds, but maybe this value is 6, maybe if you take 6 then it will be very fast, right? That is what we have seen here, and the next topic we will see in the next class with MATLAB examples, right? So we are going to see in the next class. Thank you.